All right, so we're going to look at predicting for single replacement reactions. So in our single replacement reactions, we are going to have an element react with a compound. And remember that in this one element's going to come in and replace an element in the compound. So at the end, you're still going to have an element and a compound. It will just be a different element and a different compound. Okay. Again, we're going to keep this fairly limited and simple. Our compounds are going to be ionic. So that means when we get to the product side, you're going to have to cross your charges in order to write the correct chemical formula. And for your elements, they will either be a metal or a halogen. Now, here's the thing. An element cannot just replace any element it wants. Rule 1, metals have to replace metals. Okay. So you're going to want to get out your blue periodic table and find this, what's called the activity series on the back of it. And this is the order of who is allowed to replace who. Okay. So the top of the list, which is similar to the one on the screen, but yours has a few more elements on it. Top of the list is lithium. So lithium, if it's the element that is all alone at the beginning, can come in and it can kick out any element that's underneath it on the list. So it can kick out every other metal. All right. If rubidium is the element that's by itself, it can kick out every metal except for lithium. All right. Potassium can kick out every metal except for lithium and rubidium. And gold can't kick anybody out, and gold gets kicked out by everyone. All right. So metals replace metals. All right. Halogens can replace halogens. And so that list is on the bottom on the screen. It's not on the back of your periodic table because it is the order that they are in group 17. So fluorine is the one that can replace everybody. Iodine is the one that constantly gets replaced. Okay? So this is my recommendation for how we're going to do this. Okay? So when you look at an example, walk through, we've got magnesium plus a silver nitrate. So you find the element that's by itself. Mg. Ask yourself, is it a metal or a halogen? Magnesium is a metal. So it's going to try and replace the metal inside of the compound. So magnesium is going to try and come in and kick silver out of the compound. All we do is look on the list. The only way that's going to happen is if magnesium is higher than silver on the list. And if you looked at your list, you would see magnesium is definitely higher than silver. Some of you might want to do all your predicting first, so you could just go ahead and put a little Y off to the side. When you go to write your products, that's a yes, it's going to happen. There's not a specific order you have to write them in. I find it easiest if you write whoever gets kicked out first. So it'll just be the element symbol. All right, so Ag, it'll be all by itself. Look on the periodic table in my classroom. Ag is in black, so it is a solid. Okay? And then you can put magnesium with the NO3. This is where you have to cross your charges. Mg is in group 2, so it's positive 2. And then NO3 is on the back of your periodic table. It's a -1 cross. And then we use our solubility rules from the other day, and we can tell that that'll be aqueous. And honestly, your compounds will all start aqueous inside of these. We do all of these reactions in water, just like the double displacement. Once we write it, we balance it. I always start with the compound that I just wrote. So I've got 2 N's and 6 O's. So I'll come back on the left and I'll put a 2 to get 2 N's and 6 O's. It's going to give me 2 Ags. So I've got 2 Ags, and then you can fill in the ones if you would like. Okay. Second example, I have zinc 2 chloride plus iodine. Find the element that's by itself. That would be I. Ask yourself, metal or halogen? Iodine is a halogen. So when iodine comes in, it's going to try and kick out the other halogen. All right, so it's going to try and replace chlorine. Again, this list is not on the back of your periodic table. All you have to do is look up at the periodic table. The only way iodine can replace chlorine is if iodine is higher than chlorine. Iodine is not. Iodine is the bottom of the halogens. So this would be a no prediction, and you would write no reaction. Our third one, got copper 2 sulfate and aluminum. Find the element by itself, Al. Ask yourself, metal or halogen? Aluminum is a metal. So it's going to try and replace the other metal in the compound. Aluminum is going to try and replace copper. The only way that can happen is if aluminum is higher on the list. Check your list. Aluminum is higher than copper. So this will be a yes. When we go to write our product, again, you don't have to write it in this order, but I find it easiest to write the one that gets kicked out because it is just its symbol for the most part. Copper is a solid at room temperature. And then you've got to pair up aluminum with SO4. And again, it's all about your charges. Aluminum is in group 13, so it's a 3. Sulfate is SO4 minus 2. Cross. So Al2 SO4 3 on the back of your periodic table. The solubility rules will say aqueous for that one. Gives you 2 aluminum, so I'll put a 2 there. Gives me 3 S's and 12 O's, so I'll put a 3 on the left-hand side to get my 3 S's and 12 O's. That'll give me 3 copper, so I will put a 3. Last one, find the element that's by itself. That's calcium. Ask yourself, calcium and metal are a halogen. It's a metal. When you get over here, you're like, uh-oh, there's no metal on that side. All right. If you look on your list on the back of the periodic table, hydrogen is on the list. There are metals that are able to replace hydrogen inside of compounds. Calcium is one of them. Calcium is higher than hydrogen on your list, so that's going to be a yes reaction. Calcium can come in and replace the hydrogen. All right. That means hydrogen's going to end up all alone. I'll write the H, but it's the one you've got to remember that it's one of those special elements that get the little 2. Most elements are just their symbol, but you have your 7 that get the little 2. In my classroom, it's in red, so it's a gas. And then again, you've got to cross your charges to pair up the last 2. Calcium is in group 2, so 2 plus. Fluorine is in group 17, so -1. So CaCl2. Halogen compounds are aqueous. And then we balance, we have 2 Cls, so we'll put a 2 on the left, and that fixes my H's.